So any product you buy anywhere, anytime, it doesn't just magically come into the store, right? There's a lot that went into that, and a lot of times people just think of when you have that product, what are you using? Like with this laptop or this projector, you know, we're using electricity right now. Or in your car, people always talk about the miles per gallon. But that's by no means the end of the story when it comes to the resources that went into that and the pollution that came out of it. Now, any product you have goes through these phases in some way, shape, or form. Material extraction, that's like in your car, getting iron ore out of the ground. You know, material processing, turning that iron into steel. And then manufacturing, turning it into a car. And then your use phase is where you're actually burning gasoline, right? So then waste management, you know, putting in the landfill. So any product you have goes through these phases. And in each one of those phases, it takes energy and different materials of some type, right? When you're mining coal out of the ground, you know, you're dumping mountaintops into river valleys. Well, hopefully not. And you're buying and burning diesel fuel and that type of thing. So for every step in the process, you're taking in inputs and putting out outputs, which are this pile of nasty stuff right there. And ideally, you're going to recycle a lot of those, or remanufacture or reuse. So on this slide, you can see instead of putting it in the landfill, you can reuse, remanufacture, or recycle. But in any case, all those things still take energy. So there's still inputs and outputs that go into it. You know, your truck has to pick up your bottles from your blue bin and then go take it to the thing, and they got to melt the aluminum into glass, and et cetera, et cetera. So life cycles assessment is the study of the inputs and the outputs of what's called your supply chain, which is all these previous steps to getting the product. So here's some examples of various inputs, you know, energy, food stocks, transportation, minerals, and outputs can be CO2, you know, the one that people talk about all the time now. But we pump a lot of stuff out, you know, that's by no means the end of the list there. So it's a pretty new field, and the methodology is still getting nailed down, but the two best known ways of doing it are process flow or EIO-LCA, and sometimes you can combine them. Process flow is actually where you're going and talking to the factory and saying like, hey, how much are you emitting? So it's way more detailed, but takes, you know, a PhD dissertation to get real good answers. EIO-LCA, which is what I'm going to talk about, is a quick and dirty method of that, but it has its strengths and its weaknesses compared to process flow. So the way it works, it stands for Economic Input-Output Lifecycle Analysis, which is definitely a mouthful. That's why they call it EIO-LCA. And what it uses is the Economic Input-Output Matrix, which the government compiles. And what it is every company over a certain size in the whole country has to itemize how much money they spend on different products. So if we pretend that my water bottle was made in the US, I don't know if that's true, so, but we're going to pretend that, right? So there's steel in this, or aluminum, I guess, and you know, so let's say the factory, right? So they have to buy aluminum to make this. So they have to record how much money they spend on the aluminum, how much they spend on the plastic for the cap, even how much money they spend on the paint on this thing. So all the companies have to record that. And so I forget which government institution does it, but they really assimilate all this stuff. It's kind of crazy how big the data set is for doing that. So then that you can use that to actually say, okay, so I bought this much aluminum, right? And then my aluminum guy bought this much energy from X and bought this much other stuff. So you can actually see how much money was spent per dollar of aluminum all the way through the whole economy. So it sort of takes into account the whole ripple effect there. And so the way that EIO-LCA works to calculate your, they call it emissions, you know, inputs or outputs, is it then says, okay, we can figure out per dollar of aluminum manufacture how much CO2 is emitted, how much lead is output. So per dollar, you then multiply that times the number of dollars you spend to get an approximation of the emission that comes out. So that includes the entire supply chain there. So I'm going to show you an online tool from Carnegie Mellon University. Not going to do that yet. That is pretty easy to use. So EIO-LCA.net. Moving to the right slightly. So you go to use the tool. And so it's based off this what's a product one of you guys are just dying to know the environmental impact of? iPod. Okay. So everyone always wants to know about the iPod. So I'm going to go down to semiconductors and electronic equipment, and let's see. And I will pick. Maybe it'll be in computers. So this data set is from 1997, which will talk about the fact that so there isn't actually an iPod on it.
Did you search iPod?
It's probably in computer storage device manufacturing. Because like iPod is sort of like a USB.
Is that on this?
It's right below the
I see.
highlighter.
Okay, so you can see more of a description down here. So this includes CD-ROM drives, et cetera, et cetera. So yeah, this will be good enough. So I'll select this sector. Now, you can change the inputs in here. So what this says right now is, if you buy $1 million worth of iPods, what are the greenhouse gas emissions? So how much does an iPod cost? Not $1 million. So let's just put $200 and see the greenhouse gas emissions. So the top row gives the total, right? And it's in metric tons. So 0.059 metric tons is 59 kilograms of CO2 for your iPod. And then it actually breaks it down into both the different pollutants and the sources of that. So
it's like silicon manufacturing.
So
yeah.
for one single iPod.
Yeah.
Well, this isn't iPod, but it's got
Yeah.
the silicon manufacturing.
$200 on electronic.
$200 generic electronic.
Semiconductors.
So that's how you use this model. You can on the talk. There's definitely limitations to